Okay, so hopefully you printed this out, the attachment that I sent with the assignment, and I really just want to look at two problems on it. Problem number 2, and then on the next page, problem number 4. And the reason I'm just picking those two is because I would like you to practice with 1, 3, 5, and 6. And again, they look similar to ones that we've already done. 2 and 4 are different from the others. We've never seen ones like 2 and 4, so I want us to take some time to talk about that, since those might be a little bit harder since they're so new. Again, if you really feel like a challenge and you would like to try and do it before you watch the video, then that would be great. So again, 2 and 4 is what we're going to be doing in this video. All right, so again, we don't get options here. We have to think about this on our own. So let's just say some things that we could say. So this is the first function that we've looked at that has a discontinuity, right? It is not differentiable at 2 here. All right, there would be a vertical asymptote at that point. So one thing we will know then is if it's not differentiable in the original function, then it's not going to be then the derivative will be undefined at that point. All right, so we can say because there's a vertical asymptote in our original function, there will be a vertical asymptote in our derivative. All right. Okay, so let's talk about what the derivative of each of these pieces is going to look like. So I would say that the derivative, well, first of all, if we're talking about increasing and decreasing so that we know what the slope is like, again, think about what you would say for the slope in each of these. Increasing, decreasing. All right, hopefully you said that for this part, m is going to be less than 0. It's decreasing here. And also, n is negative here. It's decreasing on this part of it. All right, so let's focus on this part right here. I'm noticing that the slope it has to be negative, but it also starts out pretty flat right here. All right, it's very close to being horizontal there. It's not horizontal there, but the slope in here is going to be close to 0, but negative because it's decreasing. And as it gets closer and closer to the asymptote, it's going to pick up some speed. All right, so like maybe this is negative 1/2 as the slope right here. Again, not the position, but in fact, maybe I'd say even less than that. Maybe it's like negative 1/10. All right, so over here at negative 8, maybe I'd put that at negative 1/10, really close to that x-axis. But then by the time it gets to negative 4, it looks closer to, let's say, maybe negative 1/2. Again, I'm totally winging this. And then when we get down to maybe like here at 0, it's actually at negative 1. Again, I'm just guessing that, thinking what the tangent line would look like. By the time I get over here to like 1/2, it's really steep. I mean, this is probably like negative 5 or something. So at 1/2, maybe it's down at like negative 5. All right. If I were to graph these, and again, I'm just estimating, if I were to graph these, it would end up looking almost exactly like the function that we have right there. Right, so that part should probably look like that. Now we could do the same thing up here, but now we're going to say that, again, because this is decreasing, that the slope here is really high, all right, very steep, but it's negative. So again, I might guess that this part right here is like, I don't know, negative 8, something like that. And so down here at 2.5, I'm going to guess that it's, really down low, like there. All right, and then we're going to keep going up. So then maybe down here, somewhere between, I don't know, maybe around 3.5, it looks like it's negative 1. All right, and then maybe at 6, it looks like it's negative 1/2. And then even here, it's going to be even closer. So something like that. Again, I'm just eyeballing it. But I would say it's going to look something like that. Right, now again, I just guessed what that's going to look like, but let's talk a little bit about what we think this function is to see if this even makes sense. So again, we've seen functions like this briefly. Most of the time we look at it when it's like this. Right? Think about what that function was called. Right, hopefully you remember this was y equals 1 over x. But that's not what we have right here, because here the asymptote, the vertical asymptote, is at 0. Here ours is at 2. So ours is probably going to be something of the form like maybe y equals 1 over x minus 2. Again, just a guess. There might be some scalar that's making it steeper or less steep than it might normally be otherwise, but I would guess something like this. So if I were to take the derivative of this, right, again, let me write it as x minus 2 to the negative 1, I'm going to get a negative 1, x minus 2, decrease the power by 1, take the derivative of the inside. All right, so we end up with y equals negative 1 over x minus 2 quantity squared. Right, again, really what we're looking at then is something like negative 1 over x squared, just with a shift. Right, so what does that look like? Well, the negative is going to flip everything. Well, actually, first let's say this. The x squared is going to make sure that everything is positive. Right, every value that we plug in there is get positives, and that negative is going to change it so that everything is negative. And so that's exactly what we have right here. And in fact, what it does is it would take this and just essentially flip this upside down. Right, so I feel pretty good about that graph. I think that that's probably pretty close to what it looks like. And again, as we discussed in class, I'm not too concerned about the steepness right here, just the big parts. Did you remember to put in the vertical asymptote there? Did you remember to make sure that everything was negative because it's always decreasing? So just different things like that. So one of you might have made this less steep, like maybe yours looks like this. That's okay. I'm fine with that. I just want you to realize the important parts are that everything's in the denominator here, or not denominator, everything's below the x-axis, and that we've got a vertical asymptote there, and that they're going in this direction. Okay. And then I want to look at number 4 on the second page, because again, this is not anything that we have seen before. All right, number 5, we've got a quadratic. Number 6, we've got a cubic. 1 is a quadratic, 3 is a cubic. So this one is something that we have not seen before. Okay, so look at it like you're looking at a piece of artwork for the first time. I really need you to think about the details. Where is there going to be a horizontal tangent line? Where is it decreasing? Where is it increasing? All right, if I had to guess, I'd say that this right down here has a slope of 0. Again, it might be scooched over a little bit, I can't really tell, but that looks like it's the lowest point right there. So m would equal 0. And then same thing, I would say that m equals 0 right here. All right, I would say that in between those 2 points, so in between x equals negative 5 and x equals positive 5, that this is decreasing everywhere. Right, so m is less than 0 here. If I were to take a guess, this does look like it's got some sort of origin symmetry to it. And I would guess that maybe like from here to here, that's a slope of down 4 over 2. So that is a slope of negative 1/2. No, rise over 1, sorry, negative 2. So I might even predict that somewhere in here that the slope is negative 2. Like so maybe at 0, m equals negative 2, at x equals 0. Now, I can't tell really what's going on greater than 5 or less than negative 5, but it does start to increase again. All right, so m is greater than 0 here. All right, but again, it looks like it's happening kind of slowly. Maybe it's going to come up and grow more quickly, but right now it looks like it's set for a slow increase. All right, so let's mark some of that on this right here. So let's first mark the spots where the graph of the derivative is going to be 0, and that's going to be at -5, and it's going to be at +5. All right, everywhere else in here, it's going to be negative. And again, I'm going to guess at 0, it's down at -2, just because it looks like, you know, maybe that point that's in between the +1 and -1 x values, that does look like for that section it's -1, or -2, sorry. All right, and so we need this to come down in here and then come back up. And again, I'm going to draw it symmetrically because our graph is symmetric. All right, so something like this. Sorry about the hairy lines. All right, and then again, it is going to be positive after this, but a slow positive. All right, maybe not as steep as that. So maybe it's going to do even something like, I don't know. Something like that, where it increases, but it increases slowly. So maybe like that. All right, that would be my guess. All right, hopefully that makes sense. And then you are going to try the rest of those problems and submit them for homework. All right, enjoy your day.